Excited to provide this video with you because I still think there's some misunderstandings on the sigma and some. I really want to clear it up. I hope you watch it. I hope you watch it a couple times if you need to. First of all, this does say sum, so that makes it a series. So immediately you know it's a summation formula. All right, but the big kicker on this one is that you see the ... That means we are going to keep doing this. We're going to keep doing this and do it. This is not a finite sum. So as soon as this is an infinite sum, okay, as soon as this goes on and on and on, and they're saying, hey, what if we were to just keep adding these? All right, so that's this formula, and it's a very straightforward, very simple formula. All we need is the r in the first term. Well, obviously, we got ourselves a 54 for the first term. And what's happening every single time? Please don't say 3. It's actually going down, and it's 1/3. So we would have 1 minus a 1/3. So we got ourselves 54 divided by 2/3, which is the same as, let's see how much we can do without a calculator, same as multiplying by the reciprocal. So that would be, what, 27 over 1, which comes out to 27 times 3, commonly known as 81. All right, so that's how we find the summation of the answer to an infinite sum. By the way, that is exactly the definition of a convergent. Okay, so just bonus points here. That's a convergent series. Why? Because as we add and add and add and add, we are converging towards the number 81. All right, next 12. These summation ones, people are making a little bit too harder than they have to be. I'm going to try to help you with that. Just be very careful. And I threw these on this review, not starting at 1 intentionally. If we started at 1 right now, we would have in here 92 terms. If it went from 1 to 92, that's very simple because we would just put in a 1, put in a 2, put in a 3, and we'd stop at 92. But what I'd like to do with you is explore something up here for a moment. Again, I've done this a bunch, but maybe it hasn't clicked. If I would have started with an I value of, let's say, 4, and I went to just 6, okay? First glance, some people would say, oh, 2 terms, but be very careful. If the idea of these problems, whoa, that's intense. I have no idea how I did that. If the idea, wow, I don't even know. Cool, very cool. How do I do that? All right, I can never do that again. Okay, we're back. But if the idea of these problems is to put in a 4, then put in the next integer, then put in the next integer, and then you stop at the top number, I hope you know that we would put in a 4, we'd put in a 5, and we'd put in a 6. But that's 3 terms, even though there's a distance between these two of 2. So remember, whenever we're finding the terms, we have to take the difference here plus 1 more. So here, I'm going to first start by just saying the number of terms on this problem. Okay, let's get that out of the way. First off, we would take the number of terms, we'd take 92 minus 54, and we would add 1. Okay, so essentially we're going to take 92 minus 54, and we're going to add 1. So when you guys put this on here, this is what right here most of you will do. You just be like, all right, 90 minus 54, that's good. I'm going to have 38 terms. You're going to get the problem wrong because the number of terms on this one is 39. 1 more. Okay, now why is that important? Well, this is a summation formula. So what we're going to do is we're going to sum up the first 39 terms. All right, now here's the problem. You may or may not look at that and know whether it's arithmetic or geometric. We have 2 formulas, all right? So you got to play around, or if you're understanding and doing a lot of these, you'll notice which ones are arithmetic and geometric. But here's a foolproof way. All right, now be very careful. As I look for the first term, okay, the first term is not putting in the number 1 because of the way this problem is made. It's actually 2 times 54. And then we minus 1. How did I get that? Well, I literally 2 times 54 minus 1. I just went through that. So the first term would actually be 108 minus 1, or 107. When I put in the second term, or sorry, when I find the second term, I'm putting in the next integer, which would be 55. And then I take away 1. So that's 110 minus 1, 109. If I did this for the third term, which is 2 times 56, 112 minus 1 is 111. I'm hoping at this point you're able to tell me that this is an arithmetic sequence and the d value is 2. Now we can keep doing this, obviously, all the way down to a sub what? Well, here's the deal. If you're sitting here thinking, oh, it's going to be a sub 92, that's not accurate. It's not going to be a sub 92 because look at this. The first term was when we put in a 54. The second term was when we put in a 55. So actually this one here is where that 39 comes from. That would be the 39th term. And what would we do? We would actually go and we would put in the number 92. And then we would, minus 1 and come up with that. Now if you want to use your second formula, you can use the 39th term. All right, I'm going to show you this. So basically the one most kids like is this one. It's 39 over 2, then we got our bracket, 2 times the first term, which we found was 107. Then we add our n minus 1, which is 38, right? And then we have times our d value. Well, what's our d value? Going up by 2 every single time. All right, so let's see what that comes out to when we fire that all in our handy dandy calculator. So now I got myself, I'm going to start on the inside. 38 times 2, so we know that's 76. So what do we got? 107 times 2, so that's 214. So we got 214 plus 38, what do we say? 38 times 2, yes, that's 76. Okay, so we're getting 290, and then we have to multiply that by 39, boom, and divide by 2. Or you can put it all in one shot, but I'm getting 5,655. All right, well, another one would be if I wanted to use this formula. This is just another option. S sub 39 equals 39 over 2, and I wanted to just take the first term, which was 107, and add to that a sub n is what your formula says. But if my formula says 39, right, then that would be this term right here. So if you guys wanted to find this term right here, you could actually use the second formula. So, you'd have to get 184 minus, that'd be 183. Okay, so if you took 183 plus 107, look at that, 183 plus 107, there it is, 290. And then just like we did before, multiply by 39, divide by 2, you're going to get the exact same answer. So either formula you use, I would suggest most of you, or I would think that most of you are going to use this one. It's a little more tedious, but more straightforward. You don't have to find that 39th term. Okay, all right. So with that said, there's obviously 2 more here. And these are going to be the geometrics. I hope you're noticing, I really hope you're noticing, once you have a variable up here, sorry, I just kind of deleted it or crossed it off. Once you have a variable up here in the exponent, that means it's repeated multiplication. If I change that to a 2, a 3, a 4, we're just going to be multiplying by another 2/3 every single time. All right, so know that, I can literally look at this problem and know that my R value is going to be 2/3. This is going to be a geometric sequence, and then we're going to add them all together. All right, so here's the thing though. If I want to lay this out, if I wanted to find my first term, remember that's putting in a 4, so I would have 7 times 2/3. The problem tells me to put in a 4 first of all. All right, so what does that come out to? So I've got myself, let me move this calculator over right here. So I've got myself 7, and I've got it times, parentheses, control, divide, 2/3, out here, raised to the 4th. You're welcome for the commentary. 112 over 81. I think that's what it says. This thing's really small. Yep, 112 over 81. Yeah, that makes sense with 3 to the 4th. Okay, so I've got 112 over 81. Now here's the deal. That right there is my first term, and that's all I'm going to need because I know my R value. Whoops, I already wrote it up here. I know my R value is 2/3. Now, how do I know this? How am I? Because I want you just to think about this. If I put a 5, that's what the next term would be. The second term would be, hey, 7, and you'd have 2/3 raised to the 5th power. That just means we're multiplying by another 2/3. Okay, so the formula doesn't need anything fancy. Here it is, going a little faster this time right now, but it's back up here. Ready? Right here. The number of terms is the difference plus 1. So 30 minus 24 is 26. So our terms are 27. So using my geometric, look up your formulas, my geometric formula, that says put my first term right there. Okay? So take my first term, which is, boom, right here. I got 112 over 81, and I'm going to multiply that by 1 minus my r value, which is 2/3, and I'm going to raise that to what power is this? Oh, 27th. This is going to be a crazy number. And then we have 1 minus 2/3, which I should have just written as a 1/3 on the bottom, but oh well. Okay, so now I'm going to do the part where you can just put it all in your calculator in one foul swoop. So then we got control divide, we got 112. Again, it jumps over and I never remember why it does that. All right, 112. I'm going to divide by the number 81. And then I'm going to take control divide. Nope, not what I wanted. Okay. Times control divide 1 minus parentheses control divide. Do you like my play-by-play on my calculator? It's pretty cool. You know, math is cool. Okay, 1 minus 2/3, and I'm going to raise that to, wow, the 27th power. And then I'm going to go down here and I'm going to say, because I'm getting lazy, 1/3. Because 1 minus 2/3 has got to be 1/3. All right, so look at that. I just look at it before I hit enter. Is that exactly what I wanted it to say? I think it was. I hit enter, and then there's your answer. And let's write it down now. I don't feel like writing it down right now because I'm being a little lazy, but if I take that and I hit enter, and then I just hit control, enter, I'll see that that comes out to, is that what it came out to? 4.14. Some reason I thought I had a different number when I went through that on my answer key, but maybe that is exactly what it came out to. So just glancing, see if I made any mistakes through here. That would be 8 over 81. I'm sorry, that'd be 16 times. Yeah, that looks good. So hopefully I didn't make any mistakes there. If I did, I'll find it and I will let you know in the comments of my video, but I think that's good. Okay, the next one's actually easy peasy. Because what we said before, our R value is 4 over 7, right? Isn't that what our R value is? Thinking about that. And our first term is actually also 4 over 7, because when you put in a 1, which is where this tells us to start, we get a 4/7. So this is an infinite sum, very obvious because it has an infinity symbol on it. We take our first term, which is 4/7, and we divide by 1 minus 4/7. So basically we are taking ourselves at 4/7 and dividing by 3/7, because 7 over 7 minus 4 over 7, 3/7, good. And division is the same as multiplying by the reciprocal, so that would be 7/3. 7's cancel, and we get ourselves the infinite sum of 4/3. No calc needed on those. All right, and that's that.